Welcome to a new lesson. In this lesson, we'll be exploring perfect squares, perfect cubes, and their roots. Before we jump into some examples, let's talk about a little bit. A perfect square is a four-sided figure that has all the sides the same and has 90-degree angles. So the first perfect square that we know of is 1 centimeter squared. We know that its sides are 1 centimeter by 1 centimeter. The next perfect square we know is twice larger, and its sides are the same as well, and we know that it is 4 centimeters squared because its dimensions are 2 centimeters by 2 centimeters. In other words, we could write that 1 centimeter squared is equivalent to 1 centimeter by 1 centimeter. Also, we know we could write the 4 centimeters squared the same way. It's 2 centimeters by 2 centimeters. These are the first perfect squares. Now, let's talk about the square root. The square root is a method of finding the dimension of a square. Meaning, if we take the square root of 1 centimeter squared, we are going to get the dimension of one of the sides, which is 1 centimeter. Same thing with the square root of 4 centimeters squared. If we take the square root of 4 centimeters squared, we will get the dimension of one of its sides, which is 2 centimeters. We could write out an entire list of the first 5 or 6 perfect squares using the same way. So when we square 1, we get 1. When we square 2, we get 4. Squared 3, 9, 16, then 25, and then 36. Again, square, we get 49, 64, 81, 100, and this 121, 144, 225, and 625. These lists of perfect squares should be memorized. Now let's take a look at the perfect cubed. Now the perfect cube is grabbed the volume instead of the surface area. 1 centimeter cubed has dimension of 1 centimeter by 1 centimeter by 1 centimeter. So 1 centimeter cubed is the same thing as 1 centimeter times 1 centimeter times 1 centimeter. Let's take a look at the second perfect cubed. The next perfect cubed is 8 centimeter cubed because its dimensions are 2 centimeters by 2 centimeters and by 2 centimeters. This means that we have 8 centimeters cubed is equivalent to 2 centimeters times 2 centimeters times 2 centimeters. Now the cube root of these values are used to find the dimension of one of the sides of this cubed. So 1 cube of centimeter cubed is 1 centimeter. This is one of the dimensions. So a cube root of 8 centimeter cubed is one of the dimensions of the cube, which is 2 centimeters. We can make a similar cube root or perfect cube list as we done for the perfect square. So for example, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and 10 cubed, we're jumping to that, is 1,000. And those should be memorized. Now let's talk about the syntax of roots. A root is composed of a radical sign, then has a specific value, which is, in this case, an example, 1,728. This number exists inside the root. This is called the radicand. Then it has an index. It's a small little value. This tells you the type of root it is, and it's cube root. And if there's a number existing outside, such as this 12, this is called coefficient. And this coefficient multiplies the root, so we don't ever write this multiplication sign. Also, a little example for you. A little example. Suppose we have a root of 100. If there's no number written there, this is always referred to as an index of 2. And if there's no value written outside as a coefficient, the coefficient is always presumed to be 1. So again, if there is no index, it's always index of 2. If there's no coefficient, it's always presumed to be 1. Let's take a look at some examples. In this example, we will determine the square root of 1296, 1296. This means that we're looking what is the square root of 1296. Remember, we don't put the index. There's no index there. So that is the question. What is this? Simplified. What we're going to do is we're going to find the prime factors of 1296. So it is good practice for you to do a factor tree, and we'll find by process of prime factorization all the possible factors of 1296. Again, it's because the last digit is odd, it's quite easy to assume that one of the prime factors could be 2. So again, on your calculator, 1296 divided by 2 is 648. Again, it's an it's an even number, so I'm sure we can factor again a 2. It's a lengthy process. Divided by 2. 324. And we're going to continue on dividing into until we can't divide by 2 anymore. So right now we're at 81. We know that it's going to be 9 times 9, and that's 3 times 3 times 3 times 3, and copy down all the 2's. So that means the root of 1296 is equivalent to 2 times 2 times 2, 1, 2, 3, 4, 4 2's, times 3 times 3 times 3 times 3. So this is your factorization. This is not our answer yet. Make sure you extend, and you could finish off with the little tail to show it finishes off your radical. Now, it's very important that you know what the index is. In this case, the index, because it's invisible, that means the index is 2. This means that we're looking at groups of 2. So we're going to look at groups and see matching. So we have one group of 2's, we have another group of 2's, and one group of 3's, and another group of 3's. This means that out of each group we'll take one of the members, which is 2, one of the members is 2, one of the members, which is 2, and 3, and 3, and then we'll multiply them. And the root of 1296 will be the multiplication of these values, which is in this case 36. And finally, this is our answer. You could double check on your calculator that it is 36. Let's take a look at a different example. We're going to determine the cube root of 1728. Now the cube root has a different index. It's an index of 3. I'm going to follow the same process of prime factorization. I'm going to use a factor tree to simplify it into our prime factors. I'm just going to jump ahead and give you the solution for the prime factorization. It's 6 2's, and we're going to get 3 3's. And now it's very important that you look at the index. The index means cube root, but what we're looking for is groups of 2 this time. Groups of 3 because of this index. So we have one group of 2, we have another group of 2, and another group of 3. And out of each group, we'll take one of the members, and we're going to multiply them together. So we'll have 4 times 3, which is 12. This means that the cube root of 1728 is 12. And this is your final answer. Let's take a look at one more example. In this example, a cube has a volume of 4,913 cubic inches. What is the surface area of the cube? Let's draw a picture of this cube. So this is our cube, and it's a perfect cube. That means all the sides are the same. Well, we don't know what these dimensions are. It's x. What we do know is that we could use a cube root of 4,913 to find this one dimension. When we know this dimension, we could find the surface area of the cube using the areas of each of the sides and add them together. So in order to find the cube root of this, we have to first prime factorize the 4,913. When we prime factorize it, you know what? Let's not prime factorize it. Let's just use your calculator and find out what this x is. In order to find the cube root in your calculator, you need to press the math button on your calculator. Then you'll get a list. And in this list, scroll down until you hit the 3 cube root function, and then press enter. Then type in the 4913, and you'll get a value of 17. This means that all the x dimensions are 17 inches. Now they're 17 inches. So now in this way we found the dimensions of this cube. But the question is ask you for the surface area of the cube. Well, if it's asking for the surface area of the cube, then we have to find all the faces and add them up. Each cube, so surface area, has 6 faces, and each face has 2 dimensions, length times width. And these dimensions are 17 by 17. So surface area is 6 times 17 inches times 17 inches. Therefore, the surface area of our cube turns out to be 1,734 inches squared. And this is your final answer. So this was a nice little introduction to the use and where does the square root and the cube come from and how can you use it.